Okay, so project 1 picks up where assignment 2 left off, and that would be here. We have the LCD panel and the whiteboard wired up to the microcontroller in the same pattern that it was wired up for assignment 2, where we had to display a phrase, a number, and a timer on this LCD panel here. So for project 1, it utilizes the same wiring pattern along with additional wiring from a manipulator that we had to construct, which consists of 2 joints, which we've labeled servo 1 and servo 2, and 2 links as well. So in PSOC, as you can see, we have 3 main functions. The first function being for theta 1, which controls servo 1, and we basically input values so that it can rotate within a 180-degree angle from its original position. And it's the same type of function for theta 2, which controls servo 2, but rather than 180 degrees, it just rotates from either a positive or a negative 90-degree angle from its original position. And the function at the bottom just controls the time in between each rotation between each servo, so that it isn't just going back and forth nonstop. There's a delay in between each movement within each joint and link. Here we have the PWM configuration, which consists of 2 digital output pins that you can see on the right hand side labeled servo 1 and servo 2. And then on the left hand side, we have a clock input that comes from the system functions. And then beneath it is a logic low input from the logic functions. Here we have the port and pin assignments for our 2 digital output pins, servo 1 and servo 2. It may be difficult to read on the image, but we have servo 1 assigned to port P17, which is pin 19, and we have servo 2 assigned to port P16, which is pin 18. So they're both side by side. You can find them on the bottom left corner of the overall system in the 2 blue ports. So the main issue we had with project 1 was that once everything was wired up how it's supposed to be, whenever the microcontroller is plugged in, you can hear the motor turn on, but it doesn't have enough power to rotate on its own. So while sitting here messing with it, I would have to push it before it will catch and then rotate the rest of the way, or it just won't. But sometimes you could see it, like you can see it catch a little bit in whichever direction it's rotating, but it won't go the full way on its own, simply because it isn't getting enough power from the desktop to make that rotation on its own. So I'll plug it up. All right, so here we have the microcontroller plugged in. You see the LED lights are on, the LCD panel is on, and the blocks came back just because we have nothing programmed to display here. So the black blocks came back, and the motor is on. You might be able to hear it. Not sure if you can hear it or not, but it's on and it's trying to rotate, but like I said, it isn't getting enough power to do it on its own. So might be able to show you here. See, I can move it. Hold on. See, I can give it a head start and it'll pick up and go the rest of the way, but on its own, it won't. And that's the best I can do. But aside from the power supply, that is the basis for project 1.